All right, good morning, everybody. So I hope it's a good new year for you. Happy New Year to your family. What I'm going to be going into for this class, as I said in the class I just have with you, is that we're going to go through the exam. Okay? Exam. So I'm going to show you now the steps that were to be attained for this exam. So end of term examination was 1.5 hours, right? And we want to work on the time management. But just for the time being, let's begin and discuss the first question. Let's go here, put my face over here. All right, so we're gonna go into Math S2, okay? And let's look at the first question. All right, so here's an example. I decided to simply use paper that was graded, full marks, and it's a good example of how students typically think. Okay, great. So let me just go into now the process. 10 minutes, there we go, 10 minutes. So in the first question, it says, remove the brackets in each of the following algebraic expressions. What do we mean by remove the brackets? If you can remember, right? There we go. If you can remember, when I said remove the brackets, I simply mean multiply, right? Multiply throughout or simply add the distributive law. So when the question says a third 9x plus 6, right? You would multiply a third by the first term and multiply a third again by the second term. So let's look at that. Here's an example. If you have a times a fraction, so in this case, 9x times a third, right? That is the same thing as saying 9x times 1 divided by 3. Let's go to the next one. If we have 6 times the fraction a third, we can simply say it's the same thing as 6 times 1 divided by 3. So this is the format, right? A whole number times a fraction is just a whole number in the numerator times that other numerator by the denominator, right? So when we have 1 divided by 3, now our new numerator is going to be the two terms. So it's going to be 9x plus 6 divided by 3 times 1, right? And then we just can remove the 1 because the 1 is just itself. So it's really just 9x plus 6 divided by 3. But here's the interesting thing now. There's two terms. Why? The plus sign separates two operations. Sorry, the plus sign separates two terms. That's why you have an operation. If I have John and Tim, I need to say an operation between them to make it an expression. So it's either John plus Tim equals my friend or John minus Tim equals just John. That's an example. You have to have an operation. So in other words, it's really 9x. It's really 9x. And then the second term is 6, right? So in other words, we have 9x divided by 3 and then 6 divided by 3. But let's not even look at the factor. Let's just work this out off the top of our head. So how many times does 3 go into 9? We know that 3 times. So in other words, 3 into 3 goes 1, 3 into 9x goes 3 times. Okay? Let's do another one. How many times does 3 go into 6? 2 times. 3 into 3 goes 1, 3 into 6 goes 2 times. So let's look at it now. We can write all of that by saying, instead of writing 6, we put 2. Instead of putting 9x, we put the 3 back with the other x that we had. So we have 3x, right, the 3 and the x plus the 2, right? And the factor that we used to simplify it was 3. So we put 3 on the outside, okay? Right, so let's look at it now. Only thing we have left to say is that the answer is really just 3x plus 2 because 3 divided by 3 gives you 1. Again, you could have taken another term and look and use this example. Let's look at another form. You just said, okay, I don't have to work out the factor part. I can just simply work it out as is. 6 divided by 3 is 2, okay? 9x divided by 3 is 3x, and that's it. You would get the same marks, but this way that I just showed you explains the process, okay? Any questions? Let Mr. Thompson know. right? This is positive. Okay. Okay, so for the next question now, you get to realize that it challenges you. It asks you a fairly simple question, but on the surface, it doesn't look simple, right? You remember saying, sir, this looks so simple, it could not be the answer. Well, yes, it is the answer. Let's look at what the question is asking. The question says, express the value 5 in each expression as an algebraic one, right? So the first expression is 5 plus 4, let's write that. The first expression is 5 plus 4 is equal to 9. So they're asking us to express the 5 in this expression as an algebraic one. Let's go back. What do we know makes an algebra term? We know it has to have known values, of course, like 9, but also it needs to have an unknown, like a letter. So 9 is a value, 9x is an algebraic term because we don't know what x is. That's the difference. Go back in your notes, right? So if I want to make 5 an algebraic term, I simply have to say, well, substitute 5 for x. I get x plus 4 is equal to 9. And that's the answer, right? Okay, because now we can solve for x and say, well, carry over the 4 and you'll find your answer. Okay, let's go to another one. 2 times 5 is equal to 12. Let's look at that. 2 times 5, let me put it in bracket. 2 times 5 is equal to 12. There we go, okay? We want to express it as an algebraic, so we just replace that 5 with an x. So we can say 2 times x is equal to 12. There we go. And that's it. Because if we want to solve for that value, all we would have to do is transpose or change the subject of the formula. So we say x is equal to 12 divided by 2, and that will give us our value, okay? And that would be our unknown. But we just want it to be an algebraic expression. So it would just be, okay, 5 plus 4 is equal to 9. The algebraic expression of that is just x plus 4 is equal to 9. And then that's the end of this section. Okay, so the next section, again, it is a follow-up. So remember what I said before that you just stated it? In question 4, you are asked to solve for it. So if you have x plus 4 is equal to 9, what is x? What is the unknown? If you can recall, the process of finding the unknown is called changing the subject or transposing. There you go. Changing the subject or transposition, right? So if we say x plus 4 is equal to 9, we do something, whether it's gonna be the inspection method, the balance method, right? You choose, right? So remember there's an inspection method and a balance method to solve. Well, let me just use one and you're gonna tell me which method I used. We're gonna say, do the opposite, right? Do the opposite of the value that's beside the unknown. So if we have x plus 4, do the opposite. What's the opposite of positive 4? Negative 4, right? But the rule states whatever you do on one side, have to do it to the next side. So it's gonna be 9 minus 4 again, right? We know that positive 4 and negative 4 cancel, so we could say x plus 0 or just say x. That gives us 9 minus 4, which is 5. So this is our answer. All right? Excellent. So I'm going to show you what I just did and go over it. My bad. Didn't know I wasn't screen sharing. So let me go back here. So as I said before, you are just going to be doing the inspection balance or another method. You're going to tell me which method is that, right? Do the opposite of the positive 4, which is -4 on both sides, and you get the value to be x is equal to 5. We know that's true because here's why. The value that we had originally was 5. No, it's not true for all cases, because say, for example, if you do one and the value is not the unknown, that doesn't mean it's necessarily wrong, right? It's just because some questions work out perfectly, but in others, it's just a coincidence, right? So don't be alarmed that if you check it, it's not the correct answer. Don't worry, it's perfectly fine. Okay, all right, so let's go to another one. Right. All right, so we're going to continue now. Let's look on the next section. So in this question now, you are asked to plot a flow chart. Anybody revise the flow chart? So the flow chart was pretty simple. It's actually one of the fun topics that we did where you just drew, just had to draw some shapes. Let's look back on an example. So here we go. This is pulled from one of the students that got full marks, right? So if you can recall from the flow chart, right, I'll tell you the page in the next class, but essentially what the question asks you is a worded problem. So it says, Paul had X apples. He sold 26. Okay, first of all, if I have a bunch of things and I gave away, what operation was done? Subtraction. So an expression to show how much apples Paul has now would be an expression that said he had X, he gave away 26, so therefore his final value that he has now is gonna be X minus 26. Understand? Okay, right? And then the question says no. Using that expression, X minus 26, each of the values there were sold for 75 cents each. Right? Let me go to the example to visualize it for you. Okay, so X minus 26 is going to be that value for how much he has now, because he gave away 26 from the X he had. Okay, now, if I tell you I have 10 coins, right, and each of them are worth 20, to find the overall value, I would say 10 times 20. So if I want to find how much each is worth and each of them is 75 cents, I multiply that expression by 75. And that's one diagram. Okay, now you put an arrow to show calculation. Remember, this is a circle or ellipse. We call it a circle, right? Oval. All right, and the next one is a rectangle that says what's going to be now the expression that's left. So after you draw it, it says draw a flow chart to show the amount of money in dollars for which Paul sold the remaining apples. Hence, using the flow chart, calculate how much money Paul sold the remaining apples for when X is equal to 94. Let's look at that. X is equal to 94. So the original expression, right? Original expression, right? Original expression, if you can recall, was X minus 26 times 75. Look at what we do. If I give you a value for X, why can't you substitute it? Look at that. X was unknown. The question says it's now 94. So substitute, right? You know those movies where they have a substitute teacher to replace the teacher that is sick or on leave, right? You substitute the X for 94, right? So now you get 94 minus 26 times 75, and that will tell you now how much money it costs for the remaining apples, right? So in other words, he had 68 apples left from the 94. Times 75 cents each, that gives you 5,100 cents. Hope everybody gets that. Okay? And now to simply write that in this expression, it could have been that you didn't know what X was. You could still work it out, because here's what you do. You just simply expand this bracket. So you say, okay, Using the distributive law, I have 75 on the outside, so that means I have two terms on the inside. It's gonna be 75 times the first term, 75 times the second term, okay? So that's two methods. Either you do the one before where you were given X, or you use the one where you don't know X and you just find the final equation. Okay, look at it. So we're gonna say now, right? 75 times X gives us 75X, right? 75 times negative 26 gives us negative 1,950. This is where I was hoping to see some persons shine. And I did see some persons shine, but I hope more persons could have picked it up, right? So now this is your final equation. You could have left it here and I will give you the full marks, because even if you just put the 94 here, you still get the exact answer. Let's prove it. Let's prove it. So let's put 75 times 96, right? Minus 1,950. Let's see what we get. We should get 5,100. It's loading up. Just for argument's sake, let me just put it here. Okay, there we go. It's loading up. So the answer, as I said, should be 5,100 or 5,000 around there. Okay, good. So this means that it's close to the value. So we know that it's correct in some way, right? So it's 5,250. And the answer that we got was 5,100. So there's some little errors with this person's calculation, but nevertheless, it's the same process, right? Okay. Okay, Google. 75 times negative 26. Okay, Google. 75 times negative 26. Okay, so I had my trusted Google help me out. Okay, so Google tells me that when you find 75 times the 94, that gives you 7,050, right? And when you got this value here, 1950, you subtract it, it does give you 5,100. So you could have used any method, both of them, and you get the correct answer. Thank you, Google. All right, so I'm gonna fast forward, right? And just go to the part that I made sure we are on the same page of, which is the circle. The inequalities are fairly simple to grasp. I'm pretty sure everybody did very well on those sections, but let's finalize the circle. Let's wrap up on the circles. So let's go here, okay? Right, it says the length of a rectangle is an expression 3x plus 2, and its breadth, which is the same thing as its width, is 8 centimeters. The area is not greater than 112 centimeters square, okay? Now it's asking you to find an inequation to represent the condition given above. Okay, so if I tell you it's not greater, then that means it is less than, okay? So, in other words, the length is 3x plus 2, right? So that means that when I put it in the equation, right, I should be able to get that 3x plus 2 times the 8 is less than something. Okay, if you understand that. So if it's not greater than 112, it's less than that. So it's, in other words, the expression would be the area of the rectangle, which is going to be 2 times the length plus 2 times the width is less than 112 centimeters squared. So that's the inequation. Let me show you an example of what somebody did. Here we go. Look at this one. 2 times 3x plus 2 plus 2 times 8 is less than 112. You could have stopped here, or you continue to solve it, and that would be the same result, right? The next part of it says, find the solution. There you go now. That's where you actually find the answer, which is now 46 divided by a third, right? And then finally it says, state the possible value of x. X is gonna be, as I said, 46 divided by a third, but now it asks you for the length of that shape. So if to find the length, you're gonna now go back to the original expression where they told you the length is something. So if you found what X is, and X is the only barrier to you finding the unknown, then that means 3 times whatever X is plus 2 will give you the length. Let's look at it, right? 3 times the X that we found, which is 46 divided by 3, plus 2 is going to be 46, because the 2 3's cancel, plus 2. That means 48 centimeters is the length. All right, let's go to the last question. I wasn't share screening again. Okay, let me explain that again. Sorry about that. All right, I thought I was share screening, but let's do that again. Okay, so as I was saying, here we go. Okay, good. Here we go. Let me just explain that again quickly. Right, the length of a rectangle is 3x plus 2. Its breadth is 8 centimeters. That means, as I said before, it's less than something. So you could express that using the equation 2 times length plus 2 times width is less than or equal to 112, which is the barrier. Okay, now the next question says you should solve it, right? Find a solution set. The solution set is this right here. Let's look at it. X for all values of X such that X is less than or equal to 46 divided by 3. So when you solve this, you express it in the solution set here. Okay. Now the next question says, state the possible values of X. So the possible values of X, as I said before, is the X is equal to 46 divided by 3. And using that value, you can now find the length, which is the unknown, because the unknown length was in an equation of the expression of 3x plus 2, right? So now you say, okay, what is x? You know it's gonna be 46 divided by 3. So when you put it in here now, 3 times 46 divided by 3 just gives you 46, because the 2 3's cancel, right? So it's now 46 plus 2, and that's just 48. And that's the length. Final question is going to be where you critically think and try to understand what is being asked. So let me just guide you through quickly. All right, look at this one. It says the area of the larger circle. What would be the area of the larger circle? You would have to deduce from the diagram. The larger circle is going to be this region here. The equation to find it, pi r squared. What's the r? 7.5. It's going to be 3.14 times the r squared, and that gives you 157 centimeters squared. The area of the smaller circle. So if you didn't even know the equation, it's already there for you, right? The area of the smaller circle, same step, pi r squared, right? R is 2.5, square that, times it by 3.14. It should be less than 157. If it is not, you know in your mind it is not correct, because the smaller circle is small than the larger one. So it has to be less area. Okay. The difference between those now, the two areas that you got, A1 being the larger one and A2 being the smaller one, you're gonna say A1 minus A2, 157 minus whatever you got for the second area, and that gives you the difference between them, right? So now it's asking you to say, hence, the area between the two concentric circles. So what does this mean? Let's say you didn't find the two areas of the circles and you couldn't get to subtract them. All you would have to do then is subtract the lengths, right? So you could say 7.5 minus 2.5. That gives me the region here, right? So now when I know that, then I find the area of that distance. So now let's look at it. Let me calculate it for you. So if you didn't find the two areas and you couldn't subtract them, you could have just found the area. You could have just subtract the lengths, then found the area. Let's look at it. So let me subtract the length, 7.5 minus 2.5. Wow, it's 5. Then I find the area of 5 centimeters. It's gonna be pi times 5 squared. And now you know, okay, it should be more than 2.5 area, but less than still 7.5. And that is the end of the exam. Any questions, let me know. If you want me to go over the middle section, please tell me, Mr. Thompson. Have a great day.